Namaste. Welcome all of you for Raman tutorial for GK. So, hi friends. Today class, science class. This is Tajuddin, and today we are discussing about the topic sound lesson. So, my dear friends, what is sound? So, I am talking, you are listening. This is a sound. Sound is a form of energy. So, we are talking about the sound. So sound is the sensation felt by our ears is called sound, and sound is also called as sound is a form of energy. So what do you mean by energy? Ability to do work is called energy, and by the sound we are able to hear the sound. Yes. So स्टूडेंट्स, आपको समझ में आया? आज हम साउंड लेसन स्टडी कर रहे हैं. तो साउंड, बहुत सारे साउंड हम सुनते हैं. ये सारे साउंड्स म्यूजिक भी हैं, नॉइज भी हैं, सारे चीजें हम सुनते हैं. सो आज हम साउंड के बारे में डिस्कस करें, सबको समझ में आएगा. तो डिस्कस अबाउट द लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. So law of conservation of energy is nothing but energy neither be created nor be destroyed, but it transfer from one form to another form. That is called as law of conservation of energy. Law of conservation of energy is applicable to the sound. So now I am talking you are listening my sound. So sound travel, how it is travel. ಯಾವುದೇ ಪ್ರಕಾರನಲ್ಲಿ साउंड ट्रैवल ಮಾಡ್ತಿದ್ರಿ. साउंड ट्रैवल इन द फॉर्म ऑफ वेव्स. ये कैसे ट्रैवल करता है, कैसा मूव करता है? साउंड ट्रैवल इन द फॉर्म ऑफ वेव्स. So now let's discuss about the production of sound. How do sound is produced? Can you tell me what are the sound you are listening in our surrounding in our daily life? We are listening the sound of DJ, TV, mobile. We are talking with our friends with the mobile. That is example of sound. The speaker, here you are seeing the speaker. Speakers vibrate and produce the sound. Sound travel in the form of waves and ear listen the sound. So my dear friends, sound is produced when the object is vibrate. Sound is produced by vibrating the objects. So good evening students. How are you all? Hope you are all of you well. So today we are discussing about the topic sound, that is continuation of the oscillation and waves, and in this oscillation waves sound topics also there. So today we are discussing about the topic sound, waves, oscillations and sound. So hope you are understanding. नमस्ते, आदाब, वेलकम टू ऑल ऑफ यू. आप सबका रामन ट्यूटोरियल में स्वागत है. सो हाउ डू साउंड इज प्रोड्यूस? साउंड इज प्रोड्यूस्ड बाय वाइब्रेशन. सो स्टूडेंट्स, साउंड कैसे बनता है, साउंड कैसे प्रोड्यूस होता है? साउंड वाइब्रेशन से प्रोड्यूस होता है. वाइब्रेशन इज नथिंग बट the oscillation or vibration is nothing but to and fro motion of an object. Vibration is to and fro motion of an object. So dear students, today we are discussing about the continuation of physics topic. Oscillation, waves and sounds is there. So as a science physics teacher, I am going to explain you about this one. So now, if any kind of the doubt you have, you can ask the question. Thanks you very much for joining the Raman tutorial. Let's discuss about the next topic. Energy required to make an object vibrate. To vibrate the object, we need energy. Energy is nothing but ability to do work. And Sound is produced provided by outside source like any kind of the source that produce the sound. So the student oscillation and vibration is nothing but to and fro motion. So the vibration is produced by, tell me the name of some musical device, sitar, guitar, drum, flute, all they get vibrate. By the vibration, sound is produced. Vibration or oscillation is nothing but to and fro motion of an object from the mean position, that is called oscillation and vibration. Yes, my dear friends, this is a English medium science class. Okay, so we let's discuss about the sound. Sound is Sound of a drum or tabla is produced by vibration of its membrane. Suppose you are taking any kind of the, this is English medium science class. Hope you understand this, my friends. So sound is produced by vibration of a membrane. If I hit to the drum, the surface is vibrate and with the help of this sound is produced. If you take a sitar and guitar, that will vibrate, sound is produced. So here that the student is hitting to the drum. By the hitting to the drum, the surface or here someone is here. The sound is produced by hitting to the drum and the sound travel in the form of waves. By vibrating air in a fluid, sound is produced. By vibrating the membrane, the sound is produced in drum and tabla. So here this is the diagram, the student hitting to the drum and the vibration will be there, sound will be there, that travel in the form of waves. So the bicycle bell also produce the sound. Sound is produced by sitar by vibrating the string, the vibrating the membrane. Sound is produced by tabla and drum. By friction in an object, sound is produced. Scratching also sound can produce. These are the sources, my dear students, my dear friends. Sound can be produced. If you fill the glass, the sound is produced. Steel glass. If we hit to the metal in school, college, that we are hitting to the metal, sound will produce. Someone guest came to our home, then we rang the bell, sound will produce. We are talking here by vibrating that here we're vibrating by the this windpipe, that sound is produced. So many things in our surrounding that produce the sound. So my dear friends, what is sound? Sound is a form of energy. तो स्टूडेंट बताइए फ्रेंड्स, साउंड कैसे प्रोड्यूस होता है? How do sound is produced? Sound is produced by vibration. Now, what do you mean by frequency? Frequency is number of oscillation in 1 second. So the meaning of frequency is number of oscillation in 1 second. So pitch. Now the dear students, pitch is the characteristics of a sound that depend upon the frequency. What is pitch? Pitch is the property or characteristics of the sound that depend upon the frequency. If the frequency is low, pitch will be low. If the frequency is high, pitch will be high. If you see here, this is the drum. The drum have the low pitch. The frequency is low. If any PT teachers using the whistle having the high frequency and high pitch. So pitch is the characteristics of a sound depend upon the frequency. Hope you understand this. So number of oscillation in 1 second is called as frequency. Its SI unit is hertz. So let's discuss about the next topic. Hope you understand this, my friends. Now we discuss about the propagation of sound. Here that is the sound box that produce the sound, and sound is travel in the form of waves. So can the in which medium sound it travel? Sound travel in solid, liquid and gas. Can the sound travel in vacuum? Now my question for the friends, can the sound travel in vacuum or space? Suppose all we went to the मून, हम सभी मून पे चले गए, मून पे हम बात कर रहे हैं, क्या आपको आवाज सुनाई देगी? Will we able to listen the sound on the surface of the moon? Is it yes or no? Please tell me. Can we listen the sound in a vacuum? Is it possible? No. Sound cannot travel. Sound cannot travel in vacuum. Sound is called as mechanical wave. Sound is called as mechanical wave. Sound need a medium. The substance through which sound is travel is called as the medium. The example of medium is solid, liquid and gas. Sound need a medium to travel. Sound cannot travel in vacuum. Yes, yes, absolutely right. Students, you guess the, my friends, you guess the right. Very good, very good. The speed of sound is more in solid. Is well done, very good. Sound cannot travel in vacuum and space. The substance through which sound is travel, that is called medium. There are three medium: solid, liquid and gas. Sound is called mechanical waves because it need a medium. And sound travel, propagate, spread. Propagate means spread. So that's why we are using propagating, we are using speaker, we are using loudspeaker, DJ. To listening the sound, we are using headphone, that is audio. We are using the mobile, that is the audio. If you are seeing the videos, this is your all the students now, all the friends now, online class, live class. This is audio in video class. Okay. Now, very good, right? Air is necessary to sound travel the sound. Now let's discuss about the next topic. When the object is vibrate, then the air particle around it start vibrating in the same wave and displace from the stable position. When we are talking the sound, we are telling something. At the time we discuss the something, the sound travel in the form of waves, the particle also vibrate. So the energy transfer from one medium to another medium. Particle will be in same position. Suppose we took a one stone, throw into the water will vibrate. So the energy transfer from one medium to another medium, particle vibrate in the same position. So the vibrating air particle exert a force to the other particle in the air so that they can displace from the rest position and start vibrating. Energy is transferred from one particle to another particle and the sound is passed from one medium to another medium or in a one medium. Yes, very good. Very good. You are right, Varchan, that your answer is right. Sound is an example of longitudinal waves. Very good. Sound is an example of longitudinal wave, and here the vibration of a particle and the wave motion is parallel to each other. The particle vibrate parallel and the wave motion is parallel, that is called as longitudinal waves. Sound is an example of longitudinal waves. Yes, absolutely right. That you are right. Now about, let's move ahead now discuss about the process is continuous in the medium till sound reach to our ear. When the sound reach to our ear, eardrum vibrate and the signal goes to brain, we identify the sound. Now, what do you mean by wave? The wave is nothing but the disturbance produced by the sound travel through the medium is called as the wave. Wave is a disturbance which travel, that is called as the wave. So wave is a disturbance which travel in the medium, that is called wave. So here that, see here, that is the wave. This is a sinusoidal wave. So number of oscillation in 1 second is called one oscillation or it is called one frequency. Frequency is number of oscillation in 1 second. So this is up and down. This is called as the one wave. So the distance between the two consecutive crest is called as wavelength, that represented by the symbol lambda. Now height of the wave is called as amplitude. So the maximum displacement from the mean position, that is called amplitude. The distance between the two crests is called wavelength. The maximum distance from the mean position is called crest. The distance between the two crests is called as wavelength. That symbol representing is lambda and the SI unit of wavelength is meter. And these are the transverse waves. Light is an example of transverse waves. So now one question for the students, my friends. Sound is an example of which wave? Whether it is longitudinal or transverse? Yes, can you guess? Sound is an example of longitudinal waves or transverse waves? Answer बोलिए. Answer ಹೇಳ್ರಿ. ಇದು ಯಾವುದೇ wave? Sound is transverse or longitudinal waves? What your opinion? Yes, please. Tell me the answer. Sound is an example of transverse or longitudinal waves. Are you listening, my friends? Can you tell the answer? Yes, very good. Brilliant answer. Yes, your answer is absolutely right. Sound is an example of, yes, longitudinal waves. So in a longitudinal waves, there is a compression and refraction is there. Your answer is absolutely right. Brilliant. Very good. Very good. Absolute. Very good. Right. Your answer is very good. That is longitudinal waves having compression and rarefaction. Transverse waves having crest and trough. So light is an example of transverse waves. Sound is an example of longitudinal waves. Brilliant, very good. Now move ahead. Let's discuss about the transverse waves. This is an example of light waves. Light waves can travel. Light can travel in space. My dear friends, light can travel in space. Now, difference between transverse waves and longitudinal waves is, see, this is the transverse wave, this is an example of light wave. So now sound waves is, these are the area when the particle are very close, that is called compression. The area where the particle are very far away, that is called rarefaction. So the difference between transfer and longitudinal waves are, the waves moving straight direction. Here the particle are vibrate perpendicular to the direction of wave motion. In a transverse wave, the particle are moving perpendicular to the direction of wave motion, but as far as sound waves are concerned, the particle are vibrate parallel to the direction of wave motion. One difference between transfer and longitudinal waves is the particle vibrate perpendicular to the direction of wave motion. As far as sound waves or longitudinal waves are concerned, the particle are vibrate parallel to the direction of wave motion. And in a transverse waves, they are forming crust and they are forming trough. But as far as sound waves are concerned, they are forming compression and rarefaction. And transverse waves need no medium. Transverse wave need no medium. It can travel in space. But sound waves need a medium to travel. So, my dear friends, you understand this. This is an example of transverse wave. The distance between the consecutive crests is called wavelength. The height of the wave is called amplitude. This is the direction of the travel of the wave. And the particle also vibrate perpendicular to the direction of the waves. It is an example of transverse waves. Transverse waves in example of light waves. It don't require any medium for travel. It forms the crest and trough. These are the properties of the transverse waves. As far as sound is concerned, as far as longitudinal waves are concerned, they are forming compression and rarefaction. Particle very close, low density, that is called as compression. When the particle are far away and the density is low, that is called as rarefaction. And sound need a medium to travel. Here the direction is parallel and speed of sound is less than speed of the light. So hope my dear friends you understand this. Now the in a medium the waves carry the energy. Let's discuss about the new topic now about sound travel in the form of waves called as mechanical waves. Sound, why do sound is called mechanical waves? Why do sound is called mechanical waves? Because it need a media. Without medium, sound cannot travel. That's why, my dear friends, sound is called longitudinal wave and sound also called as mechanical wave. Sound is forming, see here, compression and rarefaction. If this is the spring, particle are very close, that is called compression. If the particle are very far away, that is called rarefaction. Compression, they have the low pressure and low density. Here in a rarefaction, compression, rarefaction have the low frequency and density. Compression, this is the compression, they have the high pressure and high density. When the particle are very close, they have the high pressure and high density. When the particle are far away, the rarefaction that have low pressure and low density. The sound waves forming the compression and rarefaction. So this is an example of longitudinal wave. Longitudinal example is sound. So when they compress and rarefaction, what will happen? Energy is transferred from one point to another point. Very good, right? Absolutely right. You are right. Sound is called mechanical waves. It need a medium. In a longitudinal waves, particle move along the parallel to the direction of wave motion. And longitudinal waves form the compression and rarefaction. Longitudinal waves need a medium to travel. And the speed of sound is less than the speed of light. During the lightning thunderstorm in the sky, first we see the light or listen the sound. आसमान में जब बिजली कड़कती है तो पहले लाइट दिखाई देती है, रोशनी आती है. So students, first we see the light and then next we listen the sound, because speed of light is more than speed of light. Now speed of light is more than speed of sound. Now here we are discussing compression. The air surrounded it and form an area of high density called compression. Compression, when a body vibrates then compress. When the body vibrate and compress, that area is low and high density. The compressed area of the sound, that is called as compression. Compression is a part of wave in which particles of a medium are closer and forming high pressure. Absolutely right. We see first light in the sky, thunderstorm, and then listen the sound. Speed of sound is less than speed of light. Now, compression is a part of a wave of a sound where the particles are very close, where the density and pressure is very high, and this compression move away from the vibrating body, and that is called as rarefaction. With particle compression, particle very close, rarefaction, particle are very far away. Wow. So, is energy change when the wave travel from compression to rarefaction? Here, the energy is transferred. Energy is transferred from compression to rarefaction. The particle are vibrate in a same position, but for compression and rarefaction, there is a change of the energy from compression to rarefaction. Hope the student friends you understand this. Okay. Now the rarefaction is a vibrating body, vibrate back and area is low pressure, and that is called as rarefaction. Now, rarefaction is the area the waves particle of medium further away from each other, and there will be a low pressure and low density. In a compression and rarefaction, there is a transfer of energy is there. There is a here that in the waves there is a law of conservation of energy. There is a change of energy, but total energies remain same. Hope you understand this. Very good question. Very nice. So now let's discuss about the sound waves. When a body vibrates back and forth or to and fro, when a body vibrates back and forth, a series of compression and rarefaction is formed in resulting the sound waves. Very good, well done. Very nice. Oh, thank you. आप सभी का हार्दिक स्वागत है रामन ट्यूटोरियल चैनल पे. We are welcome you. We are very glad to discuss with you. Hope you are understanding this chapter. Any kind of doubt that you can ask now. Propagation of sound wave is propagation of density change, energy change. Now, sound need a medium for propagation. Now, next about the propagation. Sound waves are mechanical waves. Sound waves is called mechanical waves because it need a material medium for propagation, air, water, and steel. It is a gas, it is a liquid, it is a solid. Sound is called as the mechanical wave because it need a medium to travel. Very good, brilliant. Very good, very good. So now It cannot travel in vacuum. Let's see, discuss about this activity. Now here, students, friends, we are using the bell and we are supplying the battery, supplying the current to the battery, and this is the bell job. Here, we are creating inside the vacuum. We are not fill up the air. We are removing the air. We are removing. We remove the air. So inside there is a total vacuum. If inside air is there, we can listen the sound. If we on the button of the bell, if there is vacuum inside the this device, if totally in a bell, electric bell, if it is totally vacuum, when we on the button, can we listen the sound? If there is total vacuum in this bell jar and we on the bell button, can we listen the sound? Is it possible? My friends, is it possible to listen the sound when there is completely vacuum inside the bell jar? When we on the button of bell, is it possible to listen the sound? Very good, right. Very good, very good. It's right answer, right answer. Very good. Yes, we cannot listen the sound because sound is mechanical waves. This is an experiment. This is an activity. We are using the electric bell, supplying the current by the battery. We are removing the air by the vacuum pump, creating the total vacuum. First, if the air is there inside, we listen the sound. If we are creating the vacuum and we on the bell, we are not able to listen the sound. Absolutely right. Yes, very good. Correct, my friends. Your answer is right. Absolutely right. So, students, my friends, electric bell is suspended inside a airtight bell connected to the vacuum pump. When the bell jar is full of air, we listen the sound. But when it's pumped out from the bell jar vacuum pump, we ring the bell. No listen sound is heard. This shows that this activity This activity is called as bell and jar experiment. What do we call? Bell and jar experiment. The bell and jar experiment proves that sound need a medium for propagation. Propagation means spread. To spread the sound, we need a medium. Without the medium, sound cannot travel. That is the meaning here. Now, we let's discuss about the longitudinal waves. What do you mean by longitudinal waves? The waves in which particles of a medium vibrate back and forth in a direction, back and forth or parallel direction in which the waves is moving. The particle vibrate parallel along the direction of the waves. The waves in which particle medium vibrate back and forth are parallel direction or same direction in which waves are particle and the waves are moving in a same direction, that is called as longitudinal waves. These are the example of sound waves. Now the transverse waves are example of light. So longitudinal waves also called as mechanical waves. They need a medium to travel, and transverse waves are example of light. Here in a slinky or a slinky is nothing but it is a spring. When one end of a slinky or spring is moved up and down rapidly, other end is fixed. That shows the transverse waves. If we are using the one spring and the spring is moving up and down, so that also produces the transverse wave. Now we are discussing, let's discuss about the characteristics of the sound waves. The characteristics of sound waves are wavelength, frequency, amplitude. So the water waves, When sound is produced in a water, the water waves, if we are throw the stone in a water, the waves are vibrate, and the water waves produce the transverse waves. That is, the high and low waves are there. That is, in sea, if we go to the seashore, see that one. The water waves form the transverse waves. Now let's discuss about the wavelength, frequency, and amplitude, time period, and velocity. What do you mean by wavelength? Suppose this pen having the length 30 centimeter. What is the length of a wave? Wavelength is nothing but length of a wave. The distance between two crests is called as wavelength. But SI unit is in meter, and that is represented by the symbol that is called as lambda. Lambda, that is the why this distance is called as wavelength. Hope you understand this. Now, sound waves when combine length of a compression and adjust rarefaction, that is called as wavelength. Sound waves combine length of compression and rarefaction, that is called as wavelength. Now here let's discuss about the distance between the center of two consecutive compression or rarefaction is also called as. There are the two definitions. The distance between the compression or rarefaction, the distance between the two compression, the distance between the two crests is called as wavelength. Now we can say that minimum distance in which sound wave repeat itself, it is denoted by the Greek letter that is called as lambda. Its SI unit is meter. Now we are discussing about the frequency. So number of oscillation, number of waves in 1 second. The number of vibration per second, number of waves in 1 second. So students, the sound is affected by heat and sound is affected by temperature. Thus, that not much is affected, sound affected by the gravity, sound is affected by heat and temperature. Due to the increase of the temperature, sound is the particle that move. It affected by temperature, but it is not affected by gravitational force. So as the temperature is increases, the motion of particle increases. So that's why as the temperature increase, so the speed of sound is also increase. So sound is not affected by gravitational force, sound is affected by heat and temperature. As the temperature in our surrounding is increases, the motion of particle increases. That's why speed of sound is increases. The speed of sound is 330 meter per second. The speed of ultrasound is 1500 meter per second. So as the speed temperature is increases, this speed is go on increasing. Hope you understand this. Thank you. हाँ, उम्मीद आपको समझ में आया होगा. टेम्परेचर बढ़ने से साउंड की स्पीड भी बढ़ती है. नाउ फ्रीक्वेंसी, about frequency we have learned. Now about C. These are the different kind of waves: gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays. Right? These rays have the different frequency. The SI of frequency is Hertz. And these rays having the different wavelength and they have the different frequency. So these are the spectrum group of colors. So there are the different kind of the electromagnetic waves. These are the electromagnetic waves. The electromagnetic waves having electric and magnetic field. These are the different rays are there, they have the different wavelength and different frequency, they have different speed. Now let's discuss about the SI of frequency is hertz and the symbol of frequency is V, that is this is the V and that is read as nu. So frequency is depend upon this is the frequency. So speed of sound is the product of frequency and wavelength. If we multiply wavelength and frequency, then we are getting speed of sound. Now see here, the bigger the frequency, that is called kilohertz. Kilo means thousand. This is 1 kilohertz is equal to 1000 hertz. Just like that, we are telling that 1 kilometer is called as 1000 meter. So 1 hertz is equal to 1 vibration per second. What is 1 hertz? Right. Frequency is denoted by nu. So the speed of sound is the product of nu and wavelength. So when we multiply with frequency and wavelength, we will get the speed of sound. Now let's move ahead. Hope you are understanding. Hope you understood this. Earlier we have discussed about the mini topic. Now let's discuss about the time period. फ्रेंड्स, आप सभी को समझ में आ रहा है ना? एनी डाउट? ये लो टॉपिक था एक तो वेरी गुड, थैंक्स. So now we discuss about the time period. Time taken to complete one oscillation or one vibration is called time period. So that is the amplitude, that is the time period. Here is time period is 0.1 second per cycle. Time period, time required to pass two consecutive compression or rarefaction. So SI unit of time period is second. The time is represented by T. The frequency of wave. The relation between frequency and time period. The frequency is reciprocal of time period. As time period is more, frequency will be less. Now let's discuss about the amplitude. Amplitude is nothing but height of the wave. How high the waves are going. The maximum displacement from the mean position. Amplitude is maximum displacement from mean position. The maximum displacement from the mean position is called as amplitude. Maximum displacement of a particle of a medium from an original position, that is called amplitude. Amplitude is denoted by A and its SI unit also M. Wavelength is meter. And this sound is characteristics of pitch and loudness. Pitch. So see here, they have the low frequency, low pitch. Here high frequency, high pitch. So pitch is the characteristics of a sound that depend upon the frequency. Pitch of a sound depend on frequency or vibration. It is directly proportional to frequency. Greater the frequency, greater the pitch. Lesser the frequency, lower the pitch. Hope you understand, students. My friends, now what do you mean by loudness? If we are using the DJ, the sound become very loud. I am telling you, you listen my sound, it is a low volume. But if you listen the sound DJ, it is low volume or high volume. It is high volume. So that shows about the loudness. Loudness have the more amplitude. The loudness depend upon amplitude of a sound. Yeah, you are asking about the pitch. Pitch is a characteristics of a sound depend upon the frequency. So, yeah, very good question. Pitch. The answer for the pitch is the characteristics of a sound depend upon the frequency. Low frequency have the low pitch, high frequency have the high pitch. Hope you understand this. So here we discuss about the loudness. If you are telling to someone, the person is very far away, at that time you have to increase your voice. Suppose in a big marriage function hall, we want to tell something to the audience. The sound should be loud. At the time we are using speaker. So by speaker, the sound will be propagated to all of the people. So at that time, amplitude will be more. All people, audience will listen the song. Okay, understood? Okay, thanks. Now, loudness is measure of sound energy reaching to our ear per second. Greater the amplitude of the sound waves, greater the energy, louder will be the sound. If any person is deaf, not able to listen the sound, at that time what we have to do? We have to say loudly. Amplitude will be more, and loudness will be more, energy will be more. The short in a amplitude, less energy, soft sound will be there. The SI unit of loudness is decibel. What is the SI unit of frequency? Hertz. What is the SI unit of amplitude and wavelength? Meter. Now, loudness is proportional to square of amplitude, and loudness is directly proportional to amplitude. Now let's discuss about the velocity. Velocity is distance traveled by wave in 1 second. That is called as velocity. Distance traveled by time. So distance we have taken as wavelength. This is the t. This is the velocity. V is velocity. Distance is wavelength. T is time. The wavelength symbol is lambda. The distance we have taken as wavelength and t is time. So speed can be written as, we know that frequency is equal to 1 upon t or mu is equal to 1 upon t. So speed can be written as 1 upon t become frequency, and we are multiplying with wavelength. This is the formula for finding the speed of a sound. Okay, you understand? Hope you understand this. So velocity of sound is the product of wavelength and frequency. Frequency is mu and wavelength is lambda. So speed of a sound is the product of wavelength and frequency. Now, who is your favorite singer? आप अपना फेवरेट सिंगर का नाम बोलिए. What's music? It is good to listen or not good to listen? What is music? What is noise? Who is your favorite singer? Maybe the Harijit Singh or Shreya Ghoshal or any other singers. So there are different singers are there, different musical device are there. Everyone like music to become a relaxed, happy, excitement. We are listening the song. हम सॉन्ग सुनते हैं. Songs है हिंदी, कन्नड़ा or any song. So music is pleasant sound. The pleasant sound is called music. Unpleasant sound is called as oh. Rajesh Krishnan is your favorite singer. Oh, good, good. There are so many singers are there in that uh, Voice of India, Saregamapa. That it is a talent is there that they are showing that about the different skills. So very good. So the noise is unpleasant to the sound. Unpleasant sound is called noise. The sound above 80 decibel, that will be the noise. Now, the speed of sound in a various medium. The speed of a sound. The speed of a sound depend upon the medium. It is slowest in gas. It is fastest in solid. Sound increase with increase the humidity of air. Sound speed of light is faster than the speed of sound, that already we have discussed. Now, speed of sound temperature is increases. Speed of sound in normal temperature 330 meter per second. But as the temperature is increases, speed of sound is also increases. Now, students, any object, aircraft, bullet, rocket, they have the speed more than sound. Any object having the speed more than sound, that is called as supersonic boom. Object having the speed greater than the sound, that sound is speed is called supersonic speed, more than 330 or 340. This aircraft that having the more speed than the sound, that is called as supersonic boom, supersonic speed. Now, about the shock waves, that may be a earthquake, that may be a lightning, that may be a different things are there. Supersonic refer to speed of an object greater than the speed of sound. It produce loud sound, that the speed of the object. सबको समझ में आ रहा है ना? कोई भी मशीन अगर इस साउंड की स्पीड से ज्यादा तेजी से मूव हो रही है, तो उसके स्पीड को हम क्या बोलेंगे? सुपरसोनिक स्पीड बोलेंगे. तो इस सुपरसोनिक स्पीड में क्या होगा? ज्यादा लाइट प्रोड्यूस होगी. तो इस लाइट प्रोड्यूस होने को हम क्या बोलेंगे? शॉक वेव्स. होप माय फ्रेंड्स अर्थ आए तो. Shock waves are produced when the speed of a sound is faster than the speed of sound. This machine move very fast. If aeroplane moving in a sky, we listen the sound. That sound is coming very very large sound. In Deepavali, we are using the crackers and others. It also produce the sound. The horn produce the sound. The instrument produce the sound. The claps, they are producing the sound. By whistle, we can produce the sound. So speed of the sound more than speed, object speed more than the sound, that produce the shock wave. Now reflection of sound. Light is reflected, sound is also reflected. Bouncing back of sound is called reflection. That is called as echo. Echo means, suppose if we go to the hilly areas, you are telling the name. If you are telling, if you tell any name of your friends, go to the hill area, the reflection of sound is called echo. If you go to the Bijapur, if you tell your friend name, how many times you can listen? The effect of shock waves or sonic waves are, these are the high speed waves. Because of that, there is a noise pollution, there is a disturbance to the environment. So it will damage, affect to the human beings. So the people or government are telling that the sound should be, the speed should be the under the loudness should be under the control. There will be more loudness. There will be a more difficulty for the people to listen. So if you are go to the Bijapur Gol Gumbaz, that you are listening the echo. So the reflection of sound waves is called as echo. So listen the echo, at least we need 16-meter distance. So now we can hear echo in the time gap 0.1 second, and echo is produced when the sound is reflected. So by the echo, speed is nothing but distance by time. So next is about the reverberation. If one time reflection is called echo, if sound is reflected many times, if sound is reflected many times, that is called as reverberation. So reverberation is reflection of sound, repeated reflection of sound. So here, multiple reflection of sound from the wall or filling of fluid of a hall, that is called as reverberation. In an auditorium, any VIPs, CM or PM giving the lecture, the audience sat there, they are listening the sound, the time, that is reverberation will be there. So here, the difference between echo and reverberation. So now, application of sound, reflection of sound. So loudspeaker, Shainai, this musical instrument. In this instrument, we are applying the reflection of sound. We are listening the sound. And next about the doctor use stethoscope to find out the heartbeats. Check the heart. The doctor use the stethoscope. The doctor listen the sound. Reflection of sound is here, and they are checking the heart. It is application of reflection of sound. Next is about the soundboard. The soundboard produce the sound, and the speaker produce the sound, and it also reflect. This also example of reflection of sound. Now about the range of hearing. How much sound our ear can listen? It is 20 hertz to 20,000 hertz. This much range our ear can listen. Below the 20 is called infrasound. Above the 20, that is called ultrasound. So, whales and animals produce infrasound. Whales and elephant produce infrasound, that is less than 20, and the sound above the 20,000 hertz, that is called ultrasound. Can we listen the ultrasound? We can't listen the ultrasound. So the dogs, dolphin, bats, rats, these animals can listen the ultrasound. If anyone having the problem, they can hear the sound. Now, application of ultrasound. How ultrasound is helpful for us? It is used to investigate the internal organ of a body, just like kidney and ureters and heart. That is ultrasound used in the device that is called ECG. Which device we are using ultrasound? That is ECG, echocardiography, to check the heart, whether heart is working properly or not. Here we are using which sound? We are using ultrasound. So my dear friends, we are using here ultrasound, and in sonography to find out the problem in internal part of the body, that we are using sonography. Hope you understand this. Now, so dear friends, today we conclude our class here. The remaining we will continue tomorrow. So any kind of the talk you can ask. Thank you for joining Raman tutorial. We are very glad टू सी यू। आपका क्लास सबको समझ में आया होगा। था तो सो थैंक यू, नमस्ते for joining the Raman tutorial. Thank you very much. If you have any doubt, you can ask the question. We will continue the next class tomorrow. Thank you very much for joining the Raman tutorial. Thank you.